How many of you went home yesterday as I asked you and finished at least those 2 pages? Thanks, Thomas. And you have it in front of you now? Cool. So we left off on the one that's on the top right now. What type of equation is that? It is exponential. So what's the nice thing about exponentials? Say it again? Yeah, if you do everything correctly, you don't have to check for extraneous. Like if you make a mistake, it's not because if you're getting an incorrect solution, it's not because it's extraneous, it's because you made a mistake. So what would be the first step here? Yes, Hannah? Yeah, take log base 4 of both sides. I want to isolate the base. There's only one base here, so take log base 4 on both sides. The log base 4 cancels out the 4. Power property brings the 2x to the front. And on this side, I can already go ahead and start executing change of base. Since my mental math skills are top notch, I don't need a calculator. I know that log 64 divided by log 4 is 3 divided by 2 like they do in the hood, and I get 3 over 2. And if you feel confident that you did everything correctly, you do not need to check. I mean, you can always check in any equation. I could always get this and plug it back in and check. But if you're not getting the same, if you plug that in and you don't end up with 64, it's not because it's extraneous, it's because you did something wrong. Questions there? Yash, what do you want to do on the next one? We're going to go down to here. First step. So this one has 2 bases. Lauren, you want to help them out? Take log base 2 on both sides. Yeah, you could also take log base 32 like Yash said, but when you take the log of the bigger base, you're going to end up with a fraction, and I'm sure you don't want to deal with that, so I told you to take it as the smaller one. Power property allows me to bring 10x plus 3 to the front. Be careful on this side. There's a couple things you could do. I went ahead and just used power property to bring the 3 to the front, and then just left this as log 32 over log 2. But somebody correctly pointed out last period that if you wanted to, you could also just go ahead and take 32 to the third power. It's going to be a big number, but take 32 to the third power, and then just do log of that number divided by log of 2. That would work as well. Fax machine. So this is 10x plus 3 is equal to 3 times 5. Log 32 divided by log 2 is 5. So 10x plus 3 is equal to 15 minus 3. 10x is equal to 12. Divide by 10. X is 6 over 5. If you pull 1.2, that's okay also. Yes. Whenever there's a power, you have to multiply it. You're talking about here? Well, see, because this is the same thing as saying 3 log base 2 of 32. So the only thing I did is instead of writing it that way, I just skipped ahead to change of base. The 3 just stays in front. Hey, Isha, should I even ask, or since you haven't been here? Have you been following along from home, watching the videos? So what do you want to do on the next one? Okay, have you finished the homework already? You're always pretty up on the homework, no? So any idea what to do on the next one? No. Emily? I'll pass. Haseth? Yeah, log base 2. Do you have a question, Jonathan? You were trying to answer. Oh. So just take log base 2 on both sides. That cancels out. Power property, Hannah brings the x to the front. And then I can just already go ahead and do change of base, log 8 divided by log 2. And this side is just x plus 6. Log 8 divided by log 2 is 3. So you get 3x is equal to x plus 6 minus x divided by 2. X is 3. Booyakasha. Miles, next one. Lead the way. Thank you, Miles. Log base 7 on both sides. So 5x is equal to, Hannah, be careful with this one. I'm going to go ahead and use power property to bring the 2x plus 6 to the front, but since there's more than one term, I'm going to put that in parentheses. Then I'll go ahead and execute change of base. So that'll get multiplied by log 49 divided by log 7. Log 49 divided by log 7 is 2. So 5x is equal to 2 times 2x plus 6. 5x is equal to 4x plus 12 minus 4x, and then all the children rejoice because x was equal to 12. Do I need to check for extraneous? Why not? Exponential, yes. Good. Come on, Alexis, we're going to have a good day today. The last one there on the page. Tell me what to do. What? Good. Take log base 4 on both sides. So log base 4, log base 4. That cancels. We get 3x is equal to, move the x plus 12 to the front, of log 8 divided by log 4. This might be the first one that we've done today that you can't do in your head, but luckily we have our trusty calculator handy. So log 8 close divided by log 4 tells me 1.5. You may know that 1.5 is 3 over 2. You can use 3 over 2 if you want. I'll just use, I know you like decimals better, so I'll use the 1.5. So this is 1.5 times x plus 12. So that's 3x is equal to 1.5 x plus 18 minus 1.5x. So I get 1.5x is equal to 18 divided by 1.5. X is equal to 12. Okay, finished. Did you see Nina? Was Nina there? She was there? Okay. Any questions on anything on this page? All right. Well, the difference between this first page that I asked you to finish and the second page that I asked you to finish, they're all exponential equations. That's what they have in common. The difference is now on this page, when you start using those logs to get rid of the bases, they're going to give you irrational numbers. So to give you something to compare it to, before today, what has been the most common reason for getting an irrational number? If we were to encounter an irrational number at any point this year, what was the most common cause of it? Not fractions. Fractions do not give you irrational numbers. What has been the most common cause for us to encounter? Radicals. So, like, just to give you something to compare it to, let's say I were to ask you to take the square root of 26. Put that in your calculator. Would you agree that it's irrational? So we learned an alternative, which was to simplify, to try to do a tree. But if you try to do a tree with square root of 26, nothing comes out. So if you can't do the operation, you can't simplify it, then what were you taught to do? Somebody please. If you can't simplify it, if you can't actually do the operation, what were you taught to do? Leave it alone. Just leave it. Well, that's what we're going to do a lot here. We're going to do a lot of leaving alone. Now, one thing that the directions here don't say, but the directions with these type of equations usually do say on assessments, is to round. So we will round on these, but we're going to round at the end. So that way I can show you what the solution looks like exact and what the solution looks like estimated, rounded. Caleb, for the first one, what do you want to do? Well played, Caleb. Good. Log base 5 on both sides. So just like on the ones that we did on the last page, x minus 2 comes out with power property. But when I go to do log 200 divided by log 5, when I do change of base, bad things happen. Log 200 divided by log 5. It's an irrational number. So what I'll do is what does it mean to solve? To isolate. So I'm just going to keep on isolating then. I'll leave it alone for right now. I'll keep on isolating, and you very well may have some questions, whether it be on these tests or later on when you do like the midterm and the final, that say leave your solution exact. If you're asked for an exact solution, that's how you would leave it. The variable has now been isolated. But usually, in addition to this, the directions will say, well, now, round your answer. And really, with logs, I usually see it to either at least 3 decimals or 4 decimal places. So be aware of that. For these, I've just been doing 2. Like if it doesn't say anything, then just do it to 2. But just be aware that it could ask you to do 3 or 4 decimals. I already have the first part on the calculator's memory, so I'll just hit plus 2. And then I get 5.29 approximately. Any questions? Thomas, next one. What? Yeah. Okay. What do you want to do on the next one? Good. Log base 7 on both sides. That cancels out. It's hard to see on the screen here, but there's a negative there. So that's negative x is equal to log 21 over log 7. But when you put that into the calculator, log 21 divided by log 7. Irrational. So we'll just leave it as is for right now. Ali, what do you want to do next? Logs be tripping. Jenny? No, you don't want to add x. Isha? You were going to say the same thing? Zeke. Uncle Zeke. Definitely don't want to do that. Yeah, Yash already blurted it out. He said divide by -1, which you could do, but even better than that, if all you want to do is change the sign, multiply by -1 on both sides. That still cancels out the negative. So x is equal to negative log 21 divided by log 7. Because when you multiply by a negative, all that happens is the number changes sign. It's called the multiplication property of -1. If all you want to do is change the sign, multiply. If you divide, it works the same way. It's fine. Anything times -1 is the same thing as anything divided by -1. You get the same answer. Since I already know what log 21 divided by log 7 is, I already put that on the calculator. All I got to do is just now make it negative. So negative 1.56. Hey Lydia, you want to do the next one? But I don't like letters. Math should only have numbers. Letters are for language arts. Juan, stop showing off for the ladies. Yeah, there's a base of e, so I was kind of curious if anybody would say, well, I guess you can just take log base e, which theoretically you're doing, but we don't call it log base e. What do we call it? ln. And now ln is supposed to be a lowercase l, but then those of you that are not paying that much attention are going to think I'm writing in, like in, so I'm going to just do capitals, but it's supposed to be lowercase. So 3x is equal to ln of 6. Now, with ln's, I don't have to do change of base because my calculator is capable of doing that base. ln of 6. But spaghettios, it's an irrational number. So I'll just leave it alone until it gets isolated. What's the last step? Divide by 3. Please don't divide the 6 by 3. You're not allowed to. It's being taken up by the ln. So we would just end up with x is equal to ln of 6 divided by 3. And then if you're asked to round, you can go ahead and do ln of 6 divided by 3, which gives you about 0.60 approximately. Question, Julian? Stretching? Sophie, let's do the next one. What you want to do? We just finished doing one just like it. Go ahead, Camila. Good, just like the last time, in order to get rid of a base of e, you can just do ln on both sides. ln. So 4x plus 3 is equal to ln of 8. And then, no. Yeah, minus 3. ln of 8 is irrational, 3 is rational. Those cannot be added or subtracted. So it just stays ln of 8 minus 3. And then divide by 4. So if you want the exact solution for the variable, it is ln of 8 minus 3 over 4. But then after that, now if you want to round ln of 8, I would close it, minus 3 equals, then divide by 4. I'm getting around negative 0.23. Sophie, come on and do the next one. What do you want to do first? Good, log base 2 on both sides. Three x is equal to log 15 over log 2. Alexi, you could divide by 3, but there's ugliness going on the other side. What alternative do we have? Yes, Hannah. Yeah, multiply by the reciprocal. But be very, very careful because you're going to have to fight your urges here. You're going to say, must multiply 2 times 3, need to do it. No, don't. What am I going to write on the other side? Good, we did that the other day. Log 15 over 3 log 2. And then we can put that in the calculator. We don't need to check for extraneous because it's exponential. Yay. So we would do log 15. You could either hit equals now, or if you want to live dangerously, I think it was this period we were talking about it yesterday. Since there's more than one operation in the denominator, I'm going to put the entire denominator in a parentheses. But when I do that and then I hit 3 log, now I have 2 open parentheses. So by the time I finish it off by putting 2, how many times do I got to close it? For shizzle. And that gives you 1.30 approximately. No caps. Caroline, questions? I see you thinking back there. No questions at all? All right. Ooh. Now we're going back. What's different about this? No, you're a fraction. What's different about this? Meaning? She said it has ln. Well, I've seen ln in other problems we've done today. What's different? You're not a base. What type of equation is this? If it has ln and the variables inside of an ln, what type of equation is this? Oh dear. What does ln stand for? Natural what? Natural logarithm. What type of equation is this? It's logarithmic. It's the same thing as if it had log at the beginning. So what are we going to have to do at the end? Yeah, we're going to have to, like, not only are the steps for solving going to be the same as the ones we did before with log, but we're going to have to check for extraneous. Fair warning, I've never been too big on reviewing for quizzes. I think the whole quizzes are supposed to be formative assessments. They're supposed to be assessing as we go along. It's one of those where if we just have extra time, I'm fine. I'm not against it, but it's just there's other things we could be doing. The reason why I bring that up is, yeah, this note packet, it's nice. We've been going back and forth between logarithmic and exponentials, so I expect on Friday the equations to be fresh in your mind. But what else would you probably want to go back and review before Friday that we did last week? Well, compounding, sure, like the word problems. You want to go back and study those, and what else? Well, that I lumped those all together. The expressions, the properties of logs, expanding and condensing logs. So just keep that in mind. Anywho, so we're going to treat these the same way as we would other logs. We want to isolate the log. We've done that. The reason why you want to isolate the log, Caroline, is so you can remove it. How do you remove a log? Did it like yesterday? We did this. Yeah, it was at the beginning, but we did it yesterday. I want to say even we said most of the day yesterday. Like we didn't get to exponentials until the end of the day yesterday. Did it a big chunk of Monday too. No. How do we change? How do we? Oh, I already almost gave it away. How do we get rid of a log? Yes. Use less words. Be more efficient. Convert it to an exponential equation. We're going to convert this to exponential. What is the base of an ln? E. So E is going to be the base of the exponent to now the fourth power, and that's equal to x minus 1 over 2. Now let's show off our solving skills. Edvin, next step. No ln. Thank you, times 2. So the whole point of doing this is to get this x away from the ln. I don't want to do ln because I'll go right back to where I started. So let's just now solve times 2 times 2. So 2e to the fourth is equal to x minus 1, and then plus 1 plus 1. And then all the children rejoice because the variable has been isolated. 2e to the fourth plus 1 is equal to x. If you are asked to round, now you can go ahead and do so. We haven't had a lot of practice using the E button, so this is good practice also. 2, your E button should be around your ln button. It is for me. So 2e to the fourth, close it, plus uno. And that gives me around 110.20. But wait, there's more. Because this is a type of logarithmic equation, what must we do at the end? Check for extraneous. Okay, so look, I know with E and ln especially, there's going to be a lot of calculator involved. And actually, on this one, I can get away without it. But at the very least, I want to see that you substituted correctly. So this is going to be ln of, and this 2e to the fourth plus 1 is on top, minus an extra 1, and then over 2. And that should give me 4. So if I were to do it on paper, it's not too bad because 1 minus 1 is 0. 2 divided by 2 is 1, so that cancels out as well. So I really just end up with ln of e to the fourth. And what is ln of e to the fourth? Because the ln is going to cancel out the e. What are we left with? Yeah, just 4. So we know it's going to work out. But let's verify by calculator, just because we love our calculator. I've already put this 2e to the fourth plus 1 in the calculator. So now let's see what happens if I hit ln of that answer that I already have in the calculator minus the extra 1. Man, I got to divide it by 2. Rattlesnakes. All right, so let's do answer minus 1 in its own parentheses. Close that. Then divide by 2. And then close that. So it's taking the ln of earthing. And if I did it properly, what should I end up with? 4. Yay. I love math. I love math. M-A-T-H. I love math. No other questions? Ooh. Ooh. Any ideas? You could divide by 2. Yeah, the other option would be to get this 2 and move it up to the top as an exponent using power property. Because we do have to get rid of it. It can't be there. I would just be careful with that because that sometimes could lead to extraneous solutions that would not have been there otherwise. If I have extra logs, yeah, I have no choice. Then I have to bring the logs together. But since I only have one log, I'm going to do as Hannah said, and I'm going to divide by 2. Now, I made the mistake of leaving it as 1/2 last period, and it's fine. I got the right answer, but it got more confusing. So I'm just going to go ahead and put it at 0.5. Maybe that'll make it more calculator friendly. Jonathan, how do I get rid of the ln? Isha, say it better. Somebody not named Arzu. Kendall, do you know? Thank you. Convert to exponential. So e to the 0.5 power is equal to 2x squared. And then, yes, Isha. Thank you, Isha. Divide by 2. So we get e to the 0.5 over 2 is equal to x squared. And lastly, square root on both sides. So we get square root of e to the 0.5 over 2 equals x. Or do we? What's missing? You're an extraneous. What are we missing? Good. Square root property, plus minus. It's an equation, plus or minus. But then, yes, as Hannah said, we got to get each of those and plug them in. Now, if you notice, see, we're plugging this in for x, right? And once you were to plug it in for x, what's the first thing that would happen? If you were doing order of operations, what's the first thing that would happen? If you were plugging it in for x? Huh? You get squared. And what does the square do to any number? Makes it positive. So really what's going to happen here, the plus or minus, either they're both going to work or none of them are going to work. One of the two. Because once you square it, it's going to become positive anyways. Meaning you only really got to check it once. If the positive works, the negative should work also. So 2 ln of 2, and then this whole square root of e to the 0.5 over 2 squared. That's where I forgot last period. I forgot to put the square when I put it in the calculator. Should give you 1. Now look, you can try to start working that out. The square is going to cancel out the square root. The 2 is going to cancel out the 2 there. So really you'd just be left with 2 ln of e to the 0.5 and see if that gives you 1. That would probably be the easier thing. Actually, that is what I'm going to put in the calculator. Because the other one just got really long. So 2 ln of e to the 0.5. How many parentheses do I have open? So double close it. And there's your 1. Sleepy Caroline. Bum, bum, bum. Math is so boring. It's boring. It's boring. It's boring. Questions? How many solutions do we have there? 2, yeah. So both of them count. Even if I put that negative in there, once you square it, it becomes positive. So if the positive works, the negative has to work. Okay. Now we're back to exponentials. Alexis, first step. Very good. So 4e to the 2x is equal to 14. Juancito, next step. How? Ew. Yeah, this is time, so divide by 4. I think that should give you 3.5. I'm normally not too big on decimals, but E and ln lend themselves to decimals better. Hey, yo, Tommy, what do you want to do next? Good. And that gives you 2x is equal to ln of 3.5. Last step, you divide by 2, and all the children rejoice because they ended up with ln of 3.5 over 2. If you need to round, did I round the last one? Oh man, I forgot to round the I'll go back and round that one too. Sorry, I forgot to round the last one. Let me do this one first. ln of 3.5 divided by 2, which is approximately 0.63. Since this was exponential, you don't need to check for extraneous. On the last one that I forgot to round, I should have rounded. I know it was plus or minus. Let's see if we can do this. Let's start off with the e to the 0.5. Hit equals. Divide that by 2. Hit equals. And then take the square root of the answer. And that gives me around 0.91. Plus or minus 0.91. This is the one before. Yay, we made it. The last one of the day. And then tomorrow we can go work on our homework. Go, Emily, you go. Go, go, go. Go, Emily, go. Zeke knows. Ezekiel to the rescue. Alexi, you know? Well played, Alexi. Well played. And then Isha, what do you want to do next? We get e to the negative x is equal to 10. What do you want to do next? ln is excellent. ln. So negative x is equal to ln of 10. Yash, you can totally redeem yourself. Last step. You love dividing. It'll work. It'll work. That's fine. If you want to divide by -1, that's fine. I gave you a chance. Yeah. Yeah, if all you need to do is change the sign, just multiply by -1. But I love division. When I grow up, I want to marry a fraction. So, yeah, negative ln of 10. Since this was exponential, you don't have to check for extraneous, but you may have to round, so let's round. Negative ln 10 negative 2.30. X is negative 2.30. Any questions for me? All right, tomorrow, go straight to the lab. Don't come here and then get late to the lab and say that you forgot. We would never want to do something like that. Huh? The notes? Oh, you didn't get it already? You should have asked me at the beginning so you could have been writing all this down.